Hello, good morning everyone. I am Professor Yogita Kumbhare from Technocrats TIT Group of Institution. Today we are going to discuss about the basic computer architecture. Now, basic computer architecture. Computer architecture defines how a computer's component communicate through electronic signals to perform input processing and output operations. It covers the design and organization of the CPU, memory, storage, and input output device. Describe how these components interact through buses, control signals, and data pathways. It directly influences the overall speed, functionality, and reliability of a computer system. As we know that if we want to build any building, we are required a architecture. So here also the computer architecture is represent like a blueprint. So हम इसको easily understand करेंगे कंप्यूटर बेसिक आर्किटेक्चर को वॉन न्यूमन आर्किटेक्चर के थ्रू. So here a von Neumann architecture. The von Neumann architecture is a computer design where program instructions and data are stored in the same memory space and accessed via single bus. This design, proposed by John von Neumann in 1945, is the foundation for most modern computers and consists of a central processing unit, memory unit, and input-output devices, all connected by a system bus. The CPU, which includes the arithmetic, logic unit, control unit, and register, fetches instruction and data from the shared memory to execute the. Just like presented in the graph, input-output devices are connected through the central processing unit, which consists the control unit, arithmetic and logical unit, and memory unit. Components of computer architecture: input unit, output unit, storage unit, CPU, operating system. The structure described in the figure outlines the basic component of computer system, particularly focusing on the memory and processor. It is its main components are CPU, memory, input output devices. Key components and how they works. Central processing unit, the brain of the computer that executes instruction. Control unit. The control unit manages the flow of data and instructions, directing the entire system operations and how the processor works by sending control signals. It decided how data should move inside the computer, control inputs and outputs operation, and the fetches the instruction from memory for execution. The arithmetical logical unit, the arithmetic and logic unit is a part of the CPU that handles the calculation and decision making task. It performs all arithmetic logical operations like addition, subtraction, logical operations such as comparisons, and tasks like shifting weights and data. Registers, small high speed storage area within the CPU for temporary data storage in the program control and instruction register by. Registers are the fastest type of memory located inside the CPU. They temporarily stored information that process is currently working on, making program executions and operations faster and more efficient. Register serves as the CPU primary working memory. So, a PC counter or a program counter. It also called the instruction pointer. It holds the memory address of the instruction next instruction to be fetched and executed. Instruction registration, it's hold the current instruction that is being decoded and executed by the CPU. Memory address register, it stores or hold the address in memory for the next read or write operation. Accumulator, a common general purpose register that frequently store the intermediate or a final result of the ALU. And the general purpose register is used to temporary storage of data during the processing. Memory unit, a single unit that hold both the program instructions and the data the program operators on it. Input output devices allow data to enter into the system like keyboard, mouse, and the result to be displayed or produced on a monitor or printer. System bus. The system bus is communication system that transfer the data address between the CPU, memory, and input output devices. Applications of von Neumann architecture is personal computer and laptop. Most PCs and laptops use for a shared memory that store the both program and data, enabling efficient running of softwares like Windows or browsers, smartphones like iOS apps and Android. Example is Apple. Embedded system. Basically, embedded system is made for the specific performance or task. So microcontroller in a cars, IoT devices and appliances use von Neumann architecture for a simple, cost-effective processing of instruction and data in the same memory. For example, older ARMs. Servers and cloud computing servers utilize shared memory system to handle a large scale of softwares and data tasks for a services like AWS and Netflix. Gaming consoles you are using in regular life. So this all over about the computer architectures. Thank you.